Deducing N and L from a subshell notation. So these guys right here are what's called subshell labels, okay? And they all take the format of N, then L. N, the principal quantum number, is a number, and then L is given as a letter. So you need to know your letter designations for L. So L can be 0, 1, 2, 3, 4, 5, 6, blah, 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 blah. These are the most common ones. So L equals 0 is called S, 1 is P, 2 is D, and 3 is F. Those labels come from spectroscopy. S is sharp, P is principal, D is diffuse, and F is fundamental. You don't need to worry about it. If L goes above 3, for example, 4, 5, we just start going through the alphabet at that point. G, H, blah, 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 okay? But really, those are very rarely used, okay? So we'll just stick to the simple stuff. Not for ground state, not excited atoms. Okay, so we have to interpret this subshell label. So N equals 3 from that 3D, and then D is telling us that L has to equal 2, okay? So you just have to learn the letter labels for L, okay? So 5F would be N equals 5, and the F designation is telling us L equals 3. So 3P has N equals 3, and then P equals 1. And then 3S, N equals 3. If I can make my cursor work. Well, okay, I'm just going to write it down here. I don't know why it wanted me have it there. So 3 is N equals 3, and L equals 0 for an S designation. I wonder if it'll let me move it. There we go. I don't know why it's being funny, but that's all you need to know for this question.